We're ready to look at equations of circles, and this is a guaranteed question on the ACT. So if you haven't taken the ACT yet, you need to memorize this formula that we have right here, where it talks about the equation of a circle. And the H and the K, I want you to notice inside of those parentheses, it has the opposite sign. So that means you need to make sure that you change whatever the sign is of your center. You'll see some examples. You'll know what I'm talking about. So first, if our center is at 0, 0, the center of the circle is at 0, 0, then our equation is just x squared plus y squared equals whatever the radius is squared. So we can count our boxes, 1, 2, 3, 4, and so 4 squared is 16. So this is the equation of this circle. It's right here on the left-hand side. Now this next example on the right-hand side, we have our center is at -6, 3, and we have a radius of 4. So we always do x minus the x value of the center squared plus y minus the y value of the center squared equals the radius squared, just like our formula says. So minus minus is plus a positive, and then we leave the squared, and then just y minus 3 squared. You do not multiply these out. You don't need to FOIL it or anything. Just leave your equation exactly as is, and this is the standard equation of a circle. Let's go ahead and do some examples ourselves. So we have our H and K. We have our center of the circle. We have the radius of 4. So we'll put x minus 1, the quantity squared, right? Because we have x and then we have y. And then plus, and then y minus a -3, the quantity squared, equals 4 squared. Now I am going to go one more step and simplify that out because that's not very pretty. So that'll end up being y plus 3, the quantity squared, equals 16. So that's our standard equation of a circle. And then let's go ahead and plot. Our center is at 1, -3. And then from that, I like to go up and down our radius, which is 4 units. And then we'll just try to draw our circle as much as possible. Not very pretty, but gets the job done. Okay, let's go ahead and check out our next one. Again, we have our x and our y, 0, -3. And I say x and y, but that's actually the h and the k. Let me get those corrected. Since it's our center, we should technically call those h and then k. So x minus 0, the quantity squared, plus y minus a -3, the quantity squared, equals, and then I'm going to make sure I put 2/3 in parentheses because I have to square both the top and the bottom, so I got to put that in parentheses. So we all know that x minus 0 squared is just x, so that's going to be x squared. Drop those parentheses. We don't need them anymore whenever we have a part of it is at 0. And then plus y plus 3, the quantity squared. And then when you square a fraction, you square the top and you square the bottom, and that gives us 4/9. It's going to be kind of interesting to plot, but that's okay. So we're going to go down to 0, 3, and then 2/3. That's just going to be like 2/3 of a unit. So that is definitely just a little bitty guy down there. Okay, kind of a cute little circle. All right, now for a little bit more challenging items. We're going to be given a circle, and we need to come up with the formula. So I can already see my h and k, and I can kind of see the radius, but we're not given that specific length. So we must find the radius, which is the same thing as using the distance formula. And I know it's probably been a while for you all. So that's a big old square root. You subtract your x's and you square them, plus you subtract your y's and you square them. And this is all based on the Pythagorean theorem. That's how I remember there's a plus in the middle. Okay, so the radius would be the big old square root of, let me kind of label these instead of my h and k. I think I'll label the 3, 4 will be my, my 2's. It doesn't make any difference. It really makes no difference as long as you're consistent. But I think I'll make the outside the 2's and the radius the 1's. So we will subtract the x's, 3 minus a -1 squared plus, and then subtract the y's, 4 minus 2, the quantity squared. So minus minus is plus a positive. So that's really 4 squared plus 2 squared. So that's 16 plus 4, and that would be the square root of 20. Now I would stop here. Do not simplify this. Just leave it like it is. Go ahead and leave it as a radical. Don't simplify it. And then we're ready to plug it into our equation. I think you'll see why in just a second. So now we're ready for our circle equation. So x minus, and now I'm going to change that to the h and the k. So x minus a negative 1, the quantity squared. Just change colors on you. Plus y minus 2, the quantity squared, equals the radius squared. Okay, we know minus minus is plus a positive, so x plus 1 squared plus y minus 2 squared equals, and remember whenever we did the prereq chapter, we know whenever you square a radical, we just get the stuff on the inside, so that's just equal to 20. That's the reason I said just leave your radius as a radical, don't simplify it down. And that will be our final answer. Okay, let's go ahead and flip over to the back side. Now we are given a center and a point on the circle. So if we were to visualize this, a solution point is a point on the circle. So you're given a center and a solution point. We're just going to say point on circle. So this is really similar to the last problem that we did, that you're given the center and you need to come up with the radius. So let's run through that one more time. So to find the radius, that's the same thing as the distance formula. So that's a big old square root of, let me label which ones we're going to do which. I'll go ahead and label the center again as x1, y1, point on the circle, x2, y2. So we'll subtract the x's, negative 9 minus a negative 7, the quantity squared, plus subtract the y's, negative 14 minus a negative 8, the quantity squared. Lots of negatives. The radius is a big old square root of, let's see, minus minus is plus a positive, and we got another plus positive. So negative 9 plus 7, that's a negative 2 squared plus, and then negative 6 squared. And notice how I put those in parentheses. If you're using your calculator, I think you're just wasting time, honestly. I would recommend that you just use your brain cells with it. But if you're using your calculator, you definitely have to use parentheses. Otherwise, you will get a wrong answer. But I can just use my brain cells. Negative 2 squared, negative 2 times negative 2 is positive 4, and then 36, and then our radius is the square root of 40. And again, don't reduce it, don't simplify it, don't go decimal, just leave it like it is. And so then our answer would be, for the circle, x minus a negative 7, now ready to go for the HK part, so H and K. So x minus a negative 7 squared plus y minus a negative 8 squared equals square root of 40 squared. So x plus 7 squared plus y plus 8 squared equals 40. Our final answer. All right, let's go try another one. One more to go, and this one actually takes quite a bit more work. So we are given endpoints on a circle. So like, and these are not accurate. I'm just sketching them somewhere. So we have one endpoint, and it's the endpoint of a diameter. And so that's how I know these are going to be on the circle. And that's also how I know that the center is going to be in the middle. So we have to do a whole bunch of stuff here. We need to figure out where the center is at. And we'll need to figure out the radius. So to find the center, that's going to be the midpoint of the diameter. So a reminder of what your midpoint formula is. That's when you average the x's, and then you average the y's. I said it right. I certainly did not write it right. So we're just going to find the middle. So you average the x's, and then you average the y's. Let's go ahead and call this first point the x1 and the y1, and the second point the x2 and the y2. So our radius point, not the distance, but the radius point is going to be a -1 plus 7 over 2 and -2 plus 4 over 2. So that would be 6 over 2 and 2 over 2, or that would be 3, 1. So this point right here, and I said radius, midpoint is the center. And so that is the center of our circle. So that point, I'm going to go ahead and label as 3, 1 on my little sketch there. All right, now we're ready to find the radius. And remember, the radius is the distance formula. And that's that big old square root. I'm going to write it one more time. You subtract the x's and you square them, and then you subtract the y's and you square them based on the Pythagorean theorem. And our points that we're going to use to find the radius, it doesn't matter if you use the center and the 7, 4, or the center and the -1, -2. I think I'll use the 7, 4 just because those are positive. So I think I'm going to copy those 2 points down. So we have the center, which is 3, 1, and we have the point on the circle, which is 7, 4. And I can scroll down. Okay, so our radius is the big old square root of, we'll go x1, y1, x2, y2. So I'll subtract the x's, 7 minus 3, the quantity squared, plus subtract the y's, 4 minus 1, the quantity squared, big old square root, so that would be 4 squared plus 3 squared. So the square root of 16 plus 9, which is the square root of 25. Now, that one we know, so if you want to go ahead and simplify that, you can, down to 5. All right, and now I think that we're ready to write our equation of our circle. So we'll have x minus, now the h and the k is your center. So yeah, the h and the k is that 3, 1 point. So it's x minus 3, the quantity squared, plus y minus 1, the quantity squared, equals the radius squared. I'll go one more time because I need to square that 5, which is 25. And that will be the equation of our circle. So formulas that you need to make sure that you have down. I'm going to go ahead and highlight these. You need to have down your midpoint formula. That'll find the center. You need to have down the distance formula, and that'll find your radius. And then you need to also have down your circle formula that we had at the beginning that we've been using. So 3 formulas from this section. Alrighty, let me know if you have any questions at all.